Welcome back, friends. In today's session we are going to continue with the part of our temperature composition curve for ideal solution. In the previous session we discussed about the multiflexion, vapor pressure multiflexion phase diagram, and in today's session we are going to continue with the temperature composition curve for ideal solution. Now, the temperature composition curve for ideal solution is somewhat similar with the multiflexion, vapor pressure multiflexion phase diagram, but in this we are drawing x-axis as temperature and y-axis the composition of liquid. As we are increasing temperature, what is the composition of vapor will be seen. So we are saying that this is the graph which shows the boiling point of a solution, composition of the vapor, and the distillate. Boiling point of the solution, composition of the vapor, and the distillate. Now, if we have our solution in the container like this way, let's say there is a certain amount of solution, and then from this amount of solution, if we boil it, we'll have vapor. So if this one is enclosed, then you will have vapor in this way. So from there, vapor will be in this part, and this one will be, we call it as distillate. Or in other words, we shall see later the true meaning of a distillate. Distillate is simply the solution which tend to undergo distillation, because in temperature composition curve, as we study later, the behavior of ideal solution in a distillation. So we will have a vapor and we will have the distillate. It is sometimes called as temperature multiflexion phase diagram. Temperature multiflexion phase diagram. Temperature multiflexion phase diagram. The graph describes the behavior of ideal solution during distillation. What happens when we distillate the ideal solution? So the graph indicates the composition of liquid and its vapor. Now, in fractional distillation, always you have a flask like this one, and in this flask we normally have another outlet here. So we have let's say this is the flat bottom of the flask, and then we have the retort stand here. So from here we have the source of flame here. Let's say it is the Bunsen burner. We have the source of flame here. So what we are doing is that we have our mixture here, or we have our liquid here, and as we know, fractional distillation tend to separate the liquids with the different boiling points. So here we'll have just like a cork. We'll have water inlet, and then downward here we'll have water outlet. And this water is very important. Water inlet and water outlet. This water is very important for cooling the vapor. So here we may have a cork which just crosses here, and then if we are heating this, we'll have vapor. And after having vapor, if here we have a cool water, what will be done is that in this tube the vapor will be condensed. Condensation will take place. So if we are putting, let's say, a conical flask. If we are putting a conical flask here, there will be drops from condensation which tend to accumulate in this conical flask, and this is normally what we call as a distillate. So the composition of distillate is equal to composition of water of vapor, because vapor iko tu kwenye gas, lakini distillate iko kwenye liquid, but composition zake zinafanana, and what remains in this flask is always named as residue. Yani kile ambacho kinakuwa kimebaki. So tunachokisema ni kwamba the graph shows the temperature at which the solution boils and the composition of the vapor collected above ideal solution. Note, if a liquid has a higher vapor pressure at a particular temperature, it means that its molecules are escaping more easily. If a liquid has a higher vapor pressure at a particular temperature, that means molecules zina escape faster kwa sababu gani? Liquid na high vapor pressure. And vice versa is true, kwamba kama liquid inakuwa na low vapor pressure, molecules zinakuwa zina escape slowly. This means that if molecules escape more easily from the surface of the liquid, means that the intermolecular forces are relatively weak. Kama liquid inakuwa na high vapor pressure, so the intermolecular forces of attraction at the surface of the liquid, they are relatively weak. Only small amount of heat is applied to break them completely and boil the liquid at low temperature. Only small amount of heat is applied to break them completely and boil the liquid at low temperature. But if the vapor pressure of the liquid is low, more heat will be supplied to heat the liquid to reach the external pressure. Now consider an ideal solution produced from solvent A and B, in which A is more volatile such that it has higher vapor pressures compared to B. The high vapor pressure implies low temperature or low boiling point. So tukija kwenye diagram na kuonyesha phenomena ambayo liquid A and B, how will they behave? Ni kwamba tukiwa tuna liquid A and B, tukiwa tuna liquid A and B kwenye temperature, tunakuwa tuna diagram kama ile tu ya kwenye vapor pressure, then kunakuwa tuna boiling point, na huku pia tunakuwa na boiling point. So from there kwenye hii diagram lazima uselect, useme let's say uko naweka liquid B, liquid B, alafu kunaweka liquid A, so liquid B na liquid A. So hapa ni kulikuwa kuna reversal kidogo, kwa sababu kilichotakiwa kuwepo hapa ni kwamba A is more volatile. So if A is more volatile, the boiling point of A will be lower as compared with the boiling point of B. So even the composition will be drawn like this way. Hiyo itakuwa ni liquid composition. So in the liquid phase, as temperature increases, B ndio itakuwa nyingi. This is the boiling point for B, or boiling temperature for B, and this is the boiling temperature for A. This is the liquid phase. So what is important for you to understand here is that in the liquid phase, as temperature increases, A inabakia kwa chache. Kwa sababu gani? Ina escape faster, yenye ni more volatile, ina escape faster kuliko B. Lakini in the vapor phase, A itakuwa inaongezeka faster kuliko nani? Kuliko B. Why in the vapor phase? This is vapor phase. In the vapor phase, A itakuwa nyingi kuliko B kwa sababu gani? A is more volatile as compared to B. So let's say at a certain hapa, kwa sababu huku ni multiflexion of A from 0 to 1. Ndio maana nikwambia hapo kulikuwa kuna reversal. Multiflexion of A lazima ianze kuja huku na B ianze kwenda hivi, kule kwenye liquid B ndio kuna from 0 to 1 multiflexion of A, and here from 0 to 1 multiflexion of B. So kinachokuepo, let's say tuchukulie a certain point, let's say this one. Unaona at this point unaweza kuona kwamba at this point tunakuwa tuna kiwango cha A kwenye solution kinakuwa ni kidogo, wakati kiwango cha B kinakuwa ni kikubwa. Kiwango cha A kwenye solution kinakuwa ni kidogo na kiwango cha B kinakuwa ni kikubwa. Kwa unaweza tu kaona kwamba ni kwa jinsi gani ambavyo vitu vinakuwa vinakuwa. And in case of multiflexion, I think there are a few mistakes, but ilivyokuwa drawn kwenye exercise book is the correct one, kwa sababu ya explanation ambazo nitaanza kuzielezea. So for a mixture of A and B above, the boiling point of the mixture was expected to be a straight line joining the 2 points. Instead it the curve. If you boil a liquid mixture, you would expect to find that the more volatile liquid escaped from liquid mixture more readily than the less volatile one. This means that the high proportion of A is found in the vapor than B. This is obtained by condensing vapor to liquid and analyzing it. So tukicondense vapor hapa tukaweka kwenye liquid na tukaifanyia analysis, tutapata kujua kwamba ipi iko nyingi zaidi. So kitakachokuepo hapo ni kwamba in that diagram ni kwamba if we have this diagram, and then after having this diagram you have the temperature of A and temperature of B, then you have this curve. So at any point or at any concentration, let's say at this concentration, this will be the liquid phase, and then we'll have another composition. Let's say it is here, another composition is here. So kinachokuwepo ni nini? Ni kwamba kama composition let's say ya A kwenye liquid phase iko kiasi fulani hapa, manake tunaweza tuka end up tuka draw huku tuka match with composition ya B ile. Now let's say here the composition of A labda iwe labda let's say composition of A iwe ni kama labda 0. Let's say it is 0.3. So upande wa huku tutachukua composition ya B, this is 0.3A, tutachukua 0.3B, and then from there tutakachokifanya ni kwamba tutaweka line fulani ambayo ina join hizi point mbili, kwa sababu manake kwenye 0.3 ya A, manake huyu A anakuwa 0.7, yuko wapi? Yuko kwenye vapor. So at this point B kwenye liquid B inakuwa 0.7, but kwenye vapor, manake vapor hapa tukichora vapor itakuwa imecontain more B as compared with A. Kwa sababu gani? Kwa sababu kama A inakuwa ndogo kwenye liquid, inakuwa imeenda kwenye vapor. Ikiwa ndogo kwenye liquid, maana yake imepungua kwenye liquid, imeenda kwenye vapor. So from the graph above, if you boil that particular liquid mixture A and B, the vapor over the top of the boiling liquids or mixture has a composition which is higher or richer in A, more volatile liquid than in B. The temperature composition curve for ideal solution inaweza ikawa inaonekana kama hivyo. So again, katika hapo tunakuwa na temperature liquid moja hapo, temperature of A, then tunakuwa na temperature of B. Multiflexion zinakuwa hapo na different concentrations ambazo zinakuwa ziko kwenye diagram. This is the temperature multiflexion, temperature composition curve or temperature multiflexion curve for ideal solution, ndivyo ambavyo inakuwa inaonekana. Kwa hiyo hii hapa inakuwa ni liquid phase, huko inakuwa nini? Ni vapor phase. Kitu kinapopungua kwenye liquid phase, that means kinaongezeka kwenye vapor phase, So we are saying that above line is called tie line and is intersect the upper curve at the point of vapor composition in equilibrium with the liquid at the same temperature. Vapor composition in equilibrium with the liquid at the same temperature. The region between the two curves of the two phases region which are in equilibrium with each other, liquid and vapor. So here in between tunakuwa tuna equilibrium between liquid and vapor. Tunakuwa na equilibrium between liquid and vapor. This marks the end of our session, and to gonna discuss two basics. In the next session we discuss about the behaviors of ideal solution in distillation. If we distillate ideal solution, what will you get? If you have understood the part of boiling point, it will be very easy for you to understand the behavior of ideal solution in distillation. So thank you everybody, and let me wish you nice studies. Don't forget to subscribe to the channel. If you need these notes, go to Kipaji app and then you can buy them for a very low cost and you can afford them. Thank you, and let me wish you nice studies.